Hello, here I am going to introduce you about implementations of any 4 variable combination logic circuit or Boolean expression using 4:1 multiplexer. So there are two variable reduction methods introduced here. One is called as LSB variable reduction method and MSB variable reduction method. So I have implemented 4 input XOR gate using 4:1 multiplexer. So the function table of this 4 input XOR gate is having 4 input A, B, C, D and having 1 output F. So for 4 inputs, so this is a digital circuit. So 4 variables means the base of this digital radix associated with digital is 2. So 2 raised to power 4 is nothing but total 16 level of your truth table binary levels of this XOR gate having. So the binary pattern applicable to this 16 level is starting from 0, 0, 0, 0 to 1, 1, 1, 1. So if the 4 input variable binary pattern combination is 0, 0, 0 at that time, according to this XOR gate, we know that XOR gate for dissimilar input, output of XOR gate becomes 1. For if input A, B, C, D becomes 0, 0, 0, output of XOR gate is 0, 0, 0, 0, 1 input combination, output of XOR gate is 1 and so on. So here I am going to add one more column that is called as delayed logic. So that delayed logic I can generate it with respect to fixing the data input pins of my 4:1 multiplexer. So we know that by observing the interface of 4:1 multiplexer, 4:1 multiplexer is having total 4 data input pin, 2 select input pin and 1 data output pins. So here in terms of this 4 input XOR gate, by observing the interface of 4 input XOR gate, so 4 input XOR gate having 4 data input and 1 data output pin. So again the limitation from 4:1 multiplexer is that it doesn't have if I wish to implement this or configure my 4:1 multiplexer can be used or implementations of XOR gate, or I am going to get, in other words, I am going to reconfigure my multiplexer 4:1 multiplexer circuit that can act as a XOR gate. So the limitation from my multiplexer side is that it doesn't have a appropriate amount of select input. So here A, B, C, D is nothing but the input variable of XOR gate. Out of that 4 input variable, I am going to that 2 MSB input of XOR gate I can map with the select input pin of 4:1 multiplexer, and I am not able to map the 2 LSB select input of my XOR gate CD with respect to the select input combinations of 4:1 multiplexer. So here I can generate the logic corresponding to the variable that I am not going to map with respect to the select input of 4:1 multiplexer, that is called as C and D. So I can map that logic corresponding to I0 data input pin, I1, I2 and I3 data input pins of multiplexer. So here is we know that total min terms covered by your XOR gate is M0 to M15, because I am going to get generating the expressions of this XOR gate in SOP sum of product form, and that so I can write min term 0, output of XOR gate is 0, min terms 1, output corresponding to min terms is 1, min terms 2, output will be get 1, min terms 3, output will be get 0. So if I wish to implement this 4 input XOR gate with the help of single 4:1 multiplexer as a basic building blocks and some sort of logic gates. So here I am going to merge this min term 0, 1, 2, 3 into single min terms, because why I am going to able to merge this, because for that min term 0, min terms 1, min terms 2, min term 3, A and B variable having constant value 0. Similarly, I can merge the min terms 4, 5, 6, 7, because for this min terms A and B variable having value 0, 1. Similarly, I can merge min terms 8, 9, 10, 11, because for that min terms the A and B variable having constant value as 1, 0, and same thing will be applicable to min terms 12, 13, 14, 15. For those min terms A and B variable having constant value as 1, 1. So here by merging these minterms, I can generate this, consider that select input combination H0 S1 becomes 0 0 0 0. I can generate the logic corresponding to I0 data input pins, because we know that as per the working principle of 4:1 multiplexer, if select input combination is 0 0, at that time I0 data input pin logic will be transferred into output. If select input combination is 0 1, I1 data input pin logic will be get transferred into output. If select input combination is 1 0, I2 data input pin logic will be transferred into output. If select input combination is 1 1, I3 data input pin logic will be get transferred into output. So how we are going to get merged by inspections of this function table of 4 input XOR gate, and I can easily derive the logic corresponding to I0 data input pin, I1 data input pins, I2 data input pin, and I3 data input pins of 4:1 multiplexer. So here I am going to make this A and B as a select input, and with that we know that this is the first select input combinations of 4:1 multiplexer as a 0 0. For that I can find the relationship of this C and D variable with respect to F. If C and D become 0 0, output having value 0. If C and D become 0 1, output will be 1. 1 0, output will be get 1, and 1 1, output will be get 0. So look carefully these output columns and C and D variable column. If C and D variable will be 0 1 and 1 0, at that time output will be get 1, and C and D become 0 0 and 1 1, output will be 0. So here I can generate the logic corresponding to I0 data input pin in terms of logic gates. So this is nothing but if I am going to compare the C, D and F variable. So here I am going to get observe that the functions I can observe over here, function I can observe over here nothing but XOR. So here I0 data input pins I am going to get connected to C XOR with D. Similarly I can generate the logic corresponding to I1 in terms of logic gates. So here if C and D becomes 1 1, output of my circuit is 0. C and D becomes 0 0, output of my circuit is 1. C and D input becomes 0 1, output of my circuit is 0. 1 1, output of my circuit is 0. So for and 1 1, output is 1. So this is nothing but the, if I am going to observing the C and D variable with output of F variable, so I can easily generate the logic corresponding to I1 data input pin. I1 I am going to get connected with the help of logic gate XNOR, C XNOR with D. Similarly I can generate the logic corresponding to I2 data input pin, I3 data input pins with the help of with respect to some sort of logic gates by observing C D variable with F variable. Or in other words, instead of inspections, you can use one design method. The design method is similar to your K-map, but it is not an actual K-map. So I can generate the logic corresponding to I0 data input pins as well as I1, I2, I3 data input pins of my 4:1 multiplexer. So here I can draw one blocks, generate the logic corresponding to I0 data input pins. So here the variable I am going to get eliminated, or I am going to find the logic corresponding to C and D variable. So C can store binary value as 0 or 1, or D also store the binary value as 0 or 1. So based upon that I can divide this square into 4 cell. So if C is 0, D is 0, as per this truth table, C is 0, D is 0, at that time output will be 0, output will be 0. If C is 0, D is 1, output will be 1. If C is 1, D is 0, output will be 1. If C is 1, D is 1, output will be 0. So here I am going to get grouping this single one and grouping of this single one. So if I am going to get grouping of this single one available in this cell, so this cell is nothing but the intersections of this row 1 and column 0. So this row 1 applicable to C variable and this column 0 applicable to D variable. So here is nothing but C D bar. Same thing regarding generating the logic corresponding to this one. So this one is intersect this cell nothing but the intersections of this row 0 and column 1. So here I can generate the logic C bar D bar. So ultimately this I0 data input pins I am going to get connected to C XOR with D. This is the symbol for XOR gate, C XOR with D. Same thing I can generate the logic corresponding to I1 data input pin, I1 data input pins with respect to same variable C and D. This is 0, 1, 0, 1. I divide this. So here will be if C 0 D is 0, output of XOR gate is 1. C is 0 D is 1, output of XOR gate is 0. C is 1 D is 0, output of XOR gate is 0. C is 1 D is 1, output of XOR gate is 1. By making the group of this single one, I can generate the logic corresponding to I1 data input pins. I1 is equal to C XOR with D. With the help of same methodology, I can generate the logic corresponding to I2 data input pins, that is similar to C XOR with D only. For I3, I can generate same logic corresponding to this, that is called as C XOR with D over here. So in this way, by compressing the min terms 0, 1, 2, 3, I can generate the min terms. Compressing min 4, 5, 6, 7, I can generate another min terms, and I am going to get able to implement 4 input variable using 4:1 multiplexer. So here for implementations of 4 input XOR gate using 4:1 multiplexer, I can derive the data input pin logic I0, which is to be get connected with the eliminated variable C and D. That I0 data input pin will be get fixed to C XOR with D, I1 C XOR with D, I2 C XOR with D, I3 C XOR with D. So based upon that, whatever the logic I can generate it, derived logic corresponding to implementations of 4 input XOR gate using 4:1 multiplexer as a building block. So the variable I am going to eliminate is C and D. So here how we are going to ultimate indirectly means I am going to get derived logic corresponding to this I0, I1, I2, I3 data input pin. I0 is C XOR D. So here I can generate it, I can draw the logic diagram corresponding to D. I can put one XOR gate and output of this XOR gate will be connected to I0 data input pin. Similarly, I3 data input pins is also get connected to this XOR gate. Again, I can draw one logic gates, that is called as XNOR, and output of this XOR gate will be connected to I1 data input pin and I2 data input pin. So in this way I can configure this my 4:1 multiplexer to act as a 4 input XOR gate.